Myself, Girish, I am Assistant Professor, Department of EC, ATM College of Engineering, Mysore. In this video tutorial, I am going to explain you how to make use of serial communication using UART. And the aim of this experiment is to display hello world message using internal UART in the LPC 1768. Okay, so basically the LPC 1768 has four inbuilt UARTs, namely UART0 to UART3. So here we'll restrict our explanation to UART0, then similar you can extend to with other UARTs. Okay, so only the thing is the pin numbers you are going to configure, which is going to be vary. Okay, now you are looking at the schematic of UART which is being available in LPC 1768. You can observe this TXD0, RXD0 are the pins of transmit and receive data of the UART0. Okay, so the pins are here. The switch 21 will make use of in order to control the data transmit and received by the USB as well as LPC 1768. Suppose your switch is in like on condition, that means both towards RTS star and DTR star is nothing but request to send and DT data terminal ready. Okay, if both are towards 2 and 4, then you can download the program from USB to hardware. If the pins are the switch is moved to RTS and DTR, then it works as UART, Universal Asynchronous Receiver Transmitter. Okay, so now you can have a general block diagram here like this. So always USB to data to the UART will be connected like this. So transmit to the receiver, receiver to the transmit. So here, so what actually the data which is being sent by the UART module, how it's going to be transferred to the monitor as a serial key or a serial monitor as a in the serial fashion. Okay, so I'll brief once like UART module and registers, what it has actually, what is the function of it. Then you can recall the functions of it while you undergoing with the program. Okay, so now here LPC 1768 has four UARTs numbering from 0 to 3. Similarly, the pins are obviously RXD0 to RXD3 and TXDZ0 to TXD3. Okay, as the LPC 1768 pins are multiplexed for multiple functionalities. Okay, first they have to configure as UART pins. That's the primary aim of the experiment. Okay, so now basically these are the registers which is going to be used in the entire program. RBR, which is going to be receiver buffer register, it contains the recently received data. THR is a transmit buffer register. Okay, so here the contains the data to be transmitted. FCR, it is a FIFO control register, so in what manner the data has to be received and sent. LCR, it controls the UART frame formatting, the number of bits, number of stop bits or a parity bit if you want. So all these information can be controlled to LCR. And DLL and DLM will both together will form the baud rate value to be generated by the UART. Okay, so where DLL is the least significant bit of data rate and DLM is the most significant bit of the data rate. Okay, so DLL and DLM, these are the main registers which we are going to use. Okay, so now I'll move to the algorithms or step for configuring UART0. Step 1 is configure GPIO pin for UART0 function using pin select register. Okay, so using pins function select register, what you need to do, the selected pin should be GPIO, made as a GPIO. Okay, so for every action what we need to do is we are going to check the manual data sheet of LPC 1768 and then we are going to set the proper value by looking at the register expansion. Okay, so here Now the next step is the configure FCR, that is FIFO control register for enabling FIXO and reset both the RX and TX FIFO. Okay, so you are going to fix and reset the values of RX and TX. Okay, so and configure LCR line control register for 8-bit data, 1 stop bit, disable the parity and enable the latch, divisor latch. Okay, so now get the processor clock information from clock select. Okay, register to the 76 bits. So this is, even though actually while we preparing the hardware experiments, we have done this peak clock selection in the system file, and there is no need to do this. Okay, calculate DLM and DLL values for required baud rate from peak clock, and then load the value into DLM and DLL. Finally, clear the DLAB register to disable the access to the DLM and DLL. Otherwise, what actually is happen, if the baud rate is going to be changed, then whatever the character you are going to type in the keyboard might be not received properly. Okay, so this is the 6 steps we need to configure. After this, your UART will be ready to transmit the data or receive the data at specified baud rate. So now this is a program. So here this looks the entire program, LPC1766. So it's just header file which includes the definitions of LPC1768. UART0 initialization should be declared first. So this is a subroutine. Okay, and UART0 IRQ handler, as we said, nested vector interrupt controller is the flexibility that is present in the LPC1768. So that is to be declared here. Unsigned character, receive data, receive buffer and receive index. Similarly, unsigned character, receive flag and transmit flag. So here in the main part of the program, initialization of the system, core clock update are the common. As we said, the PLL and clock information is going to be updated by these two functions. And UART0 initialization. Once you initialize the UART0, it's ready to receive and send the data, right? So now it will going to check the receiver flag whether it is equal to 0. If it is not equal to 0, then it is transmit the register which is going to be loaded with the received data. Whatever the receiver data which is available, if the flag is not 0, okay, that data will be moved to transmit register. And then you check the transmit register, transmit flag, okay, TX0 flag. If it is equal to 0, then transmit flag, transmit buffer data will going to be saved into the receiver. Okay, it will going to send into the receiver. Okay, now here transmit flag, again you should reset into 0 in order to check for any other transmission which will occur. Okay, now I will move to UART initialization. Okay, so initialization means you need to enable UART0. As I said, we have 4 UARTs. Okay, peripheral should be enabled. That power for the UART0 should be enabled. That is P control of peripheral. Okay, so if you move with the 8, the last digit, that means 0, 1, 2, 3. So third bit, if it is 1 in the P count register, it will going to enable the UART0. Okay, pin select 0 and pin select 1. So this is going to be enabled for P0.2 to transmit and receive. Okay, now UART0 LCR is a line control register. So in the last 2 nibbles, what actually it will do is the last 4 bits, first 2 bits will belongs to word length. Okay, and then third bit is stop bit, and the 4th bit is going to be responsible for parity enable. Okay, so based on the values which is mentioned for 8-bit word length, 1 stop bit, parity, disable, enable the divisor latch. So based on the value which is mentioned in the provided by the UART LCR register in the data sheet. So 83, if you load 83, it will going to move into 8-bit word length along with a 1 stop bit. And DLM and DLL, so it's the least significant bit and it's the most significant bit of data rate in the UART register. If it is loaded with 13, then we are going to have baud rate of 9600. The calculation formula will be shown later. Okay. So here again LCR line control register is again configured with 8-bit word length. Okay. So then FCR is a FIFO control register. What actually it is going to do. So main function of FIFO control register, it can store 16 byte of data received on the UART without overwriting. If the data is not read before the queue is filled, okay, then new data will be lost and the overrun error will be occurred. Okay, so here bit by bit it is going to store, so that action will be set by moving the value by looking at the 32-bit value of the register called as FCR, and then IER, which is going to be enabling the interrupt for the transmit and receives. Okay, transmit and receive interrupt enable register. So if you are moving with 033, is nothing but 0.2 and 0.3 pin numbers are going to be 0, 1, 2, 3. So last 2 digits are the configurable pins of your transmit and receive pins in the UART. So similarly, those values will be changed into interrupt enabling. Okay, now after initialization, what we will do is we do call NVIC, that is nested vector interrupt control, okay, of enabling the IRQ with the IRQ number for the UART0. This is going to be assigning the channel in order to enable. Okay, what it will do, the IRQ handler, what it will do, check. It is going to check the interrupt identification register, namely IIR, as a interrupt status. So interrupt status will always be equal to 0.06, masking other than transmit and interrupt data indicator. I am showing the value here, only 006 for the one for transmit and one for receive. Okay, so here now in the interrupt status, whether you are checking for transmitting or receiving, if you are checking for transmitting, so if interrupt status is ampersand with 0x02, if it is equal to 02 means transmit interrupt is occur, then clear the flag. So set the flag of transmit buffer, else you check whether the receive data is available. Okay, once you check whether transmit interrupt is occur or whether you have to check receiver data is available. If transmit data interrupt is occur, then reset the transmit flag and then you send the data into receive buffer register. Okay. Otherwise, what you need to do is you need to check the receive data which is available in the RBR and you need to send into transmit register or TS star. Okay. So then else if interrupt status is compared with 04 value, if it is equal, then receive data is available. That means, okay, then the receive data should be loaded to RBR, that is receive buffer register. Then from this it's going to be loaded into transmit buffer to other side, and once you receive the data, you reset the flag once again for next reception. Okay, so this is what the way of writing the program for UART control, not display the hello world. Okay. Now this is the formula for baud rate calculation. P clock, that is the processor clock, divided by 16 into 256 into DLL plus DLM into 1 plus divide, add value and multiple value. Okay, so which is going to be 0 for UART0. Okay, and we will let you know the calculation once we come to the laboratory. Okay. Now let us look at the demonstration video how we are going to read the character from PC to hyperterminal or the serial port terminal. Okay, so thank you. I hope you understood the program flow of UART program. So in order to display hello world in the hyperterminal, so now I will show you how to download the program and how to execute with a hyperterminal. So the first command, as we done in the previous example, dmessage in order to test the device ID. So you can observe here, that is TTY USB 0 is the device ID which is generated by system. Now I need to call the hex file of mine. So that is lpc21isp-control. The complete path of the hex file have been saved as a hello world.x file. So followed by baud rate and clock frequency. Now I'll download the program into hardware. So just check if any errors are there. So recheck the connections if it is happening. Now you can observe that the program has been downloaded. If you are getting that now launching the brand new code, you need to just reset the hardware in order to get your output. Now let us come to the hardware connections. So connections is any FRC is not required here. So only the communication cable which is work as a UART mode for this experiment is good enough, and this is power supply as you done. Now here the important part of the experiment here is this switch 21. As I said, switch 21 works in dual mode. If it is in on condition, it will download the X file into hardware. If it is in off condition, then it works for a UART. So this experiment belongs to UART. So now I'll switch off the switch 21. So and I'll reset my code. Okay. So once you reset the code, so next part is you need to launch the hyperterminal here. So I already opened serial port terminal here. Okay, otherwise you can search the serial port and you can open the serial port. So here make sure that the configuration, the port has to be taken as your device ID. Okay, so port, as we before downloading we have checked it, it's a device ID is TTY USB 0. So you need to select this, and baud rate we have given that is 9600, that is 9600. So say enter. Then so it is ready to accept the characters from the keyboard. Now I'll type hello world. So simultaneously you can observe that hello world which is being displayed on the port terminal. So the important part here is if that switch 21 is going to be turned on, then no character will be taken from the keyboard. Now let us demo that also. Now I'll go back to hardware where I'll make my switch 21 as in on condition. Now I'll go back to my keyboard and I'll try to type something. So see here the any characters being typed by your keyboard which is not read. So that means this experiment is work as UART with the help of switch 21. So this is what the hardware configuration which is made in the ARM Cortex M3 microcontroller. Thank you.